Hello everyone, I am Dr. Aparna, Associate Professor and Head of the Department of Mathematics and Management Science. Today I am going to explain the applications of Rolle's theorem. The statement of Rolle's theorem is, let f of x be a function such that f of x is continuous in closed interval of a comma b, f of x is differentiable in open interval of a comma b, and f of a is equal to f of b, then there exists a point c belongs to open interval of a comma b such that f dash c is equal to 0. This is the statement of Rolle's theorem. Rolle's theorem is helpful tool when analyzing traffic flow in traffic engineering. Now I am going to solve some of the problems related to Rolle's theorem. First question is, verify Rolle's theorem for f of x is equal to 2x cube plus x square minus 4x minus 2 in minus root 3 comma plus root 3. So here given function is f of x is equal to 2x cube plus x square minus 4x minus 2. So clearly f of x is a polynomial function. Here clearly f of x is a polynomial function. We know that every polynomial function is continuous and differentiable. Therefore, clearly f of x is continuous in the interval minus root 3 comma plus root 3, in the interval minus root 3 comma plus root 3, and differentiable in open interval of minus root 3 comma plus root 3. Here clearly the given function is continuous in the interval minus root 3 comma plus root 3 and differentiable in minus root 3 comma plus root 3 open interval. Here first of all we are going to calculate f of a value. F of a means f of, here a is equal to minus root 3. F of minus root 3 is equal to, sub is equal to 2 into minus root 3 whole cube plus minus root 3 whole square minus 4 into minus root 3 minus 2. Simplifying, finally we will get this value will be equal to 1 minus 2 root 3. After simplifying we will get f of a value is 1 minus 2 root 3. Next we are going to calculate f of plus root 3 value. Here the given function is, f of x is equal to 2x cube plus x square minus 4x minus 2. By substituting x is equal to plus root 3 in the above function, we have 2 into root 3 whole cube plus root 3 whole square minus 4 into root 3 minus 2. After simplifying, finally you will get f of plus root 3 will be equal to 1 plus 2 root 3. 1 plus 2 root 3. When this value will be equal to f of b. Here b is equal to root 3. But from the statement of Rolle's theorem, f of x must satisfy 3 conditions. First condition is f of x must be continuous function in closed interval of a comma b. Second condition is f of x is differentiable in open interval of a comma b, and third condition is f of a is equal to f of b. Only the 3 conditions are satisfied, only the given function then Rolle's theorem can be applicable. So therefore here f of a is equal to 1 minus 2 root 3 and f of b is equal to 1 plus 2 root 3. Therefore, f of a value is not equal to f of b. Therefore, f of x does not satisfy the third condition of Rolle's theorem. Therefore, For this function, f of x is equal to 2x cube plus x square minus 4x minus 2 case, the given function does not satisfy the third condition of Rolle's theorem. Therefore, Rolle's theorem is not applicable. Rolle's theorem is not applicable. So, we cannot apply Rolle's theorem for this function in the given interval minus root 3 comma plus root 3 case. Now, I am going to explain another problem. That problem satisfies the Rolle's theorem condition. Coming to the second question. Now, I will explain the second question. Verify Rolle's theorem. Next question is verify Rolle's theorem. Verify Rolle's theorem for the function f of x is equal to x minus a whole power m into x minus b whole power n, where m comma n are positive integers in closed interval of a comma b. So here given function f of x is given that f of x is x minus a whole power m into x minus b whole power n. Clearly f of x represents a polynomial function of m plus nth degree. So here when you are differentiating this function, we have f dash x is equal to is nothing but d by dx of f of x. That is equal to d by dx of, here what is f of x? X minus a whole power m into x minus b whole power n. So after that, for calculating the derivative of the function, we have to apply d by dx of uv formula. D by dx of uv is equal to u into dv by dx plus v into du by dx. So now f dash x value will be equal to u into, what is u here? U is x minus a whole power m. X minus a whole power m into d by dx of v. What is v? X minus b whole power n. X minus b whole power n. U into derivation of v plus v into, v is here x minus b whole power n into derivation of u, d by dx of u is x minus a whole power n. That is equal to x minus a whole power m into, when you are differentiating x minus b whole power n with respect to x, we have n into x minus b whole power n minus 1 into derivation of x minus b with respect to x is 1, plus this term is, second term is x minus b whole power n into derivation of the next term is derivative of x minus a whole power n is n into x minus a whole power n minus 1 into differentiation of x minus a with respect to x is 1. After that, from these two terms take common x minus a whole power m minus 1 into x minus b whole power n minus 1. When you are taking common, the remaining value will be equal to m plus n into x minus na plus mb. By taking common x minus a whole power m minus 1 into x minus b whole power n minus, from these two terms you will get this step. So but here we are going to verify it. Is it Rolle's theorem is applicable for the given function or not? So here what is f of a here? But here f of a is equal to, here f of x is x minus a whole power m into x minus b whole power n minus x minus b whole power n. Then f of a is equal to 0, and by putting x is equal to b in f of x, you will get f of b is also 0. Therefore, f of x is equal to x minus a whole power m into x minus b whole power n is clearly satisfies all the conditions of Rolle's mean value theorem. So First one is clearly f of x is a polynomial function. Since here f of x is a polynomial function, every polynomial function is continuous and differentiable. Therefore, clearly f of x is a continuous function in closed interval of a comma b, and f of x is equal to x minus a into whole power m into x minus b whole power n is a polynomial function. Clearly, every polynomial function is differentiable function. And also from these 2 points, clearly f of a is equal to 0 and f of b is also 0. Therefore, f of x satisfies all the conditions of Rolle's mean value theorem. Rolle's mean value theorem. F of x satisfies all the conditions of Rolle's mean value theorem. Therefore, from the statement of Rolle's theorem, we have f dash c is equal to 0. From the statement of Rolle's theorem, we have f dash c is equal to 0. Therefore, f dash x is equal to x minus a whole power m minus 1 into x minus b whole power n minus 1 into m plus n into x minus na plus mb. Put x is equal to c in the above expression we have. Put x is equal to c in the above expression we have f dash c is equal to c minus a whole power m minus 1 into c minus b whole power n minus 1 into m plus n into c minus na plus mb. According to the statement of Rolle's theorem, f dash c value is f dash c is equal to 0. According to the statement of Rolle's theorem, f dash c is equal to 0. Therefore, c minus a whole power m minus 1 into c minus b whole power n minus 1 into m plus n into c minus na plus mb is equal to 0. From this we have m plus n into c minus na plus mb is equal to 0. Since this is of the form capital A into B into C is equal to 0, implies either A0 or B0 or C0. But here C, so that's why, but since C belongs to A comma B, C minus A whole, since C belongs to open interval of A comma B, then C minus A whole power m minus 1 is not equal to 0 and C minus B whole power n minus 1 not equal to 0. Therefore, only one possibility is m plus n into c minus na plus mb is equal to 0. From this we have c is equal to, simplifying we will get c is equal to na plus mb by m plus n. So this value is clearly belongs to open interval of a comma b. Therefore, from the Rolle's theorem, finally we can calculate the value of c is na plus mb by m plus n. Okay, thank you students.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.